Hey everyone! Today, we're taking a deep dive into the world of brain-computer interfaces, or BCIs. Think mind-controlled computers, prosthetic limbs responding to your thoughts, even virtual reality experiences powered by your brainwaves. Is this the stuff of science fiction, or something closer to reality? Let's break down the technology, its potential, and the big questions surrounding BCIs. A BCI is a bridge between your brain and a computer. It reads the electrical signals your brain cells produce when you think, focus, or feel. Think of those signals like a secret code, and the BCI is the decoder. It learns to recognize patterns in your brain waves that correspond to specific thoughts or intentions. Imagine you're wearing a BCI headset and think about moving your arm. The BCI detects that specific brain activity and translates it into a command, like moving a cursor on a computer screen or controlling a robotic limb. This is the core of how BCIs work. You might think BCIs sound futuristic, but the concept is surprisingly old. Since the 1970s, scientists have been studying ways to capture and understand signals from the brain. Early on, this involved surgically implanted electrodes. Nowadays, there are also non-invasive options like EEG headsets. So why all the buzz about BCIs now? Well, technology has advanced rapidly. We have better sensors, more powerful computing, and sophisticated machine learning to analyze brainwaves. Companies like Elon Musk's Neuralink are pushing the boundaries, with visions of super-high bandwidth brain-computer connections. Let's get a little technical for a moment, because understanding brainwaves is key to grasping BCIs. Our brains are constantly humming with electrical activity. Neurons, or brain cells, communicate using these tiny electrical signals. Brainwaves come in different frequencies. Slow delta waves are associated with deep sleep, theta waves with drowsiness or meditation, alpha waves with relaxation, beta waves with alertness, and gamma waves with intense focus or complex thinking. Each type of brainwave offers clues about a person's mental state. BCIs can learn to interpret these patterns, giving us a window into your thoughts. Here's where things get exciting. You don't need to be a neuroscientist to start learning about BCIs. While cutting-edge research happens in labs, there's a growing DIY movement and accessible resources for curious minds. Online courses can teach you the basics of brainwave analysis. There are even simple tools and kits that let you build your own basic EEG devices and experiment with translating brain activity into actions. This opens up the world of BCIs to anyone with an interest and willingness to learn. The potential benefits of BCIs are astounding. Imagine restoring movement and communication to people with paralysis, new therapies for neurological conditions, or hyper-realistic gaming experiences powered by your thoughts. But the promise of BCIs goes beyond that. BCIs could reshape how we learn, create, and interact. They might unlock new levels of human-computer collaboration, or completely redefine our idea of ability. With any powerful technology comes responsibility. We need to tackle the ethical questions head-on. What about privacy? If our thoughts are readable, what safeguards do we need to protect our inner mental world? There's also the risk of creating a digital divide. If BCIs become widely available, will there be an unfair advantage based on who can access and use them? And then there's potential misuse. Could BCIs be used for manipulation or unwanted influence? These are the conversations we need to have now while the technology is still developing. The future of brain-computer interfaces is full of possibilities and challenges. It's up to us, as a society, to guide its development. Get educated about BCIs, discuss the ethical implications, and demand transparency from companies working in this field. This technology has the potential to change the world. Let's make sure it changes it for the better. Let me know in the comments.